All right. So, uh, let's see. Hopefully you can hear me. I think I unmuted myself. I got a notification that I was muted still. Here we're going to continue with 2.3, the remainder and factor theorem. So we did, I think it was 920. So let's do one that has this as a divisor. Okay. Remember, for synthetic division, it's supposed to be x minus c. But here, it's not x minus c, it's 2x minus 3. All right. So we have a coefficient in front of that x. So what we want to do is something different. Okay, it's a little different from what we're used to. So I'm going to do 23, and 23 also has something else that I'll talk about. And I want you to try 24. All right, and that's it. So here, for 23, I'm going to write down this. I'm going to do something first before I put in synthetic division form. All right, I'm writing everything out. And then I'm going to put this long fraction bar to divide it by 2x minus 3. All right. Now, do I need to do this? No, not really. But I wanted to show you something. So what I'm going to do is I'm going to divide this. I'm dividing this thing by 2. So, because I want to make this coefficient 1 to make it like this, right? To make it x minus c. So in order to do that, I'm going to divide this by 2. I'm going to divide this by 2. I'm going to divide this by 2. I'm going to divide everything by 2. Divide everything by 2. And then when you do, we end up getting 6x to the 5th plus 5x to the 4th minus 9x cubed minus 12. Almost made a mistake. Minus 6x squared minus 4. All right. Divided by x minus 3 halves. So there's our c. Our c is 3 halves. So x minus 3 halves, that equals 0. You get your c is x is 3, 2. All right, so that's our c. Okay, so let's do synthetic division. And I'm going to put my c out here. I forgot what color I used last time. I'm going to make it purple. So 3 halves. And I'm going to put my coefficients over here. 6, 5, -9, -6, and -4. Whoa, 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 wait a minute. Here we have x to the 5th. Here we have x to the 4th, x cubed, x squared. Where's our x? All right, so notice that our x term is missing. Because we don't have an x term, what it is actually, let me move this. It's actually a 0 coefficient. All right, it's the same as 0x, because 0 times x is nothing. That's why we don't see anything there, because our coefficient is 0. You want to make sure to put everything in this correct place. So if there's no x term, or if there's a x cubed term that's missing, or x to the 4th term that's missing, you want to make sure to put a 0 there. Okay. Otherwise, everything is gonna be wrong. All right, so make sure to put that 0 there. All right, and then we have our constant, -4. Placeholders. Yeah, make sure to have those placeholders. All right, so how do we do this? Remember, we're gonna do a series of bringing it down and then multiplying and adding. So let's do it. Now, what color should I use? Okay, yes, do this. So here we're going to bring down the first one. You get 6. And then we're going to multiply. Remember, we're multiplying with that 3 halves. So remember, if you want to do it on the side somewhere, 3 halves times 6. The 2 goes into 6 3 times. So 6 divided by 2, basically. 6 divided by 2 is 3. And you have 3 times 3 is 9. Okay. So you get 9. And then add. So multiply, add. So 5 plus 9 is going to give us 14. And then multiply 14 times 3 halves. 3 halves times 14. You could do 3 times 14 first and then divide by 2, but that's going to give us a pretty big number, 42. That's not too bad. But here, let's divide by 2. 14 divided by 2 is 7. 3 times 7 is 21. And then add -9 plus 21. It's going to give us 12. And then multiply. If you want to do it in your head, you can. So 12 divided by 2 is 6 times 3 is going to give us 18. And then add -6 plus 18 is going to give us 12. And then multiply. And it's the same thing as before. So 18. And then add. You get 18. And then multiply. So 18 divided by 2 is 9 times 3 is 27. And then add. Now this is our last one. This is our constant. So I'm going to put that, oops, I'm going to put a box here to separate. That's our constant term. That's our remainder. -4 plus 27 is going to give us 23. All right. So there is our answer. So we're going to put 6, +14, +12, +12, +18, and then we're going to put a 23 here. Now this is a little different, so it's going to be, so get ready. Here you go. So let's put those variables. So it was x to the 5th, so we're going to make it 1 less. It's always 1 less, so x to the 4th. And then x to the 3rd, x to the 2nd, x, and then a constant. And then we're going to put our divisor on the bottom. Now we had, our c was 3 halves. Okay. So x minus 3 halves. However, we don't want to write it as a fraction. We don't want a fraction in a fraction. So we want to simplify that. So we're going to multiply just this one, just this term. What are we going to multiply it by? by that denominator to get rid of it. So we're going to multiply everything here by 2. So multiply this by 2, multiply this by 2, and multiply this by 2. So we divided by 2 in the beginning. Now we're bringing it back. We're multiplying that 2 just for this term, though. Okay? Because that's the only one that has that fraction, that denominator. So here, 6x to the fourth plus 14x cubed plus 12x squared plus 12x plus 18, and then plus 23 times 2 is 46 over 2x minus 3. Ta-da! And that's it. All right, so I know it's a lot of work. Try that one. Try 24. All right, I don't think there's any, yeah, there's no missing terms there, so you won't have any zero coefficients. Um, Maybe I should have done 25. Oh well, it's okay. All right, so let's do this. Put this in the notes first. All right, so now we're going to talk about the remainder theorem. So the remainder theorem states that if polynomial f of x is divided by x minus c, then the remainder is f of c. What? So basically, whatever our remainder is going to be the solution, right? Yeah, so whatever our remainder is going to be the solution. Remainder is the solution. And you will see it here. All right, and then we also have synthetic substitution. So sometimes it's you wouldn't want to multiply, or you wouldn't want to like do all those powers. So in those cases, we can do synthetic substitution, which is just solving a function using synthetic division. All right, I'll put this over here as well. So let's try it with this. Okay, here they gave us our C already. All right, so remember that's x minus 3. This would be x minus 3. This would be x minus 4. This would be x minus 5. This one over here would be x plus 6, right? All right. But here they're giving us our C's already. I'm gonna move this to the left here so there's some space. And let's try, I want you to try one that has a 0 in it, zero coefficient. Why don't you try 32? All right. And for 32, notice that there is going to be a missing space. So there should be a 0 coefficient. I'm going to do one that has a 0 coefficient as well. Let's do 34. Yeah. Okay. All right. So we have 6. It's our C. And then our coefficients, 4, 8, -6, -5, 6, and -4. Wait, I thought I was supposed to have a zero coefficient. Oh, I forgot my x to the fourth. Remember, there's that x to the fourth. That's the zero. All right. So I'm going to move this over here, this a little bit. All right, and here we go. So bring this down. We get 4, multiply. We get 24. Add. You're going to get 32. Multiply. Oh no. 192. Add. You get 192. Oh boy. What did I get myself into? I really should have done this problem beforehand. All right, so 192 times 6, uh, 2, 5, no, yeah, 5, 11. Yeah, I think that's right. Then we're going to add the -6 plus 1,102 is going to give us 1,146. Yeah, and then multiply. Gotta be kidding me. Who comes up with these numbers? All right, I'm going to use the calculator. I'm sorry. 1146 times 6, 6,876. Yeah. And add 6,000. I'm going to tilt it. 6,871. That's just looking at the answer. Oh boy. These people are crazy. Whoever wrote this book. All right. So we have the 6,871 times 6. 6,871 times 6. 41,226. Mm-hmm. All right. And then we're gonna add 41,232. Multiply. All right. 41,232 times 6. All right. So you get 247,392. Add that, and we get 247,388. And there you go. That's our remainder. All right, so what that means is f of 6 is equal to 247,388. So there you go. It's probably easier than plugging in that 6 for all of those x's, right? And then multiplying and then adding and subtracting, all that. Well, there you go. That's what it means. The remainder theorem. So try 32. 32 isn't going to be too, okay, a pretty big number too. That's not this big. All right, there you go. So we just learned the remainder theorem, and we learned that people who write math textbooks are a little crazy. They go number crazy. All right. So the next thing that we're going to talk about is the factor theorem. The factor theorem says that if the remainder is 0, then x minus c is a factor of the function. Okay. So if your remainder is 0, then x minus c is going to be a factor of that function. All right. And so here you go. Here's some synthetic division and remainders. If R is a remainder obtained after a synthetic division of f of x by x minus c, then the following statements are true. R is the value of f of c. So R is the solution of that function after substituting that c in the function. If R is equal to 0, then x minus c is a factor of f of x. If R equals 0, then c is an x-intercept of the graph of f. That's what it means to be the solution. And if R is equal to 0, then x minus c is a solution of f of x equals 0. Whoo, all right. And we're going to look at this one. All right. I really wish I had done these beforehand. Ooh, okay. So use the factor theorem to determine if the binomials given are factors of f of x. Use the binomials that are factors to write a factored form of f of x. Oh boy. All right. If you want to try 38, feel free to. I'm not gonna ask you to though. Okay. So let's look at 39. Oh, sorry. If you want to try 39, feel free to. That way you can check the book, see if you get the answer. All right. I'll do 38. All right. So the first one that we want to check, we're going to check x plus 2 first. So here, this is our c is -2. Remember, you always want to think opposite. Here the c is positive 1. Let's put this. Our first c is negative 2. Let's check. We have our coefficients are 1, negative 2, negative 9, 1, and 6. Let's bring down that first one. And it's multiplying. 1 times negative 2 is going to give us negative 2. Add those together. We get negative 4. Multiplying. Negative 4 times negative 2 is positive 8. Add those two together. You get negative 1. Multiply. Just a bunch of multiplying and adding. Negative 1 times negative 2 is positive 2. I keep changing the color. There you go. Too soon. And then 1 plus 2 is 3. 3 times negative 2 is negative 6. Dun 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 dun. All right. So here, and then add those two together. And we get 0. Yay! So since our remainder is 0, yay. So that means negative 2 is a solution. All right. So x plus 2 is a factor. All right. Now, we can actually, if this is also a factor, if x minus 1 is also a factor, then we can technically plug it into the original one, that 1, negative 2, negative 9, 1, and 6, or we can put it into this one. All right. Simplify it even more. So I'm going to put it into that second one, this one down here. Why? Because it's less work. All right. And if it is a factor, then it will work. We will get 0. If it's not, then it's not a factor of the original one. All right. So here our c is 1. You get 1, multiply, 1, add, negative 3, multiply, negative 3, add, get 3, sorry, negative 4, and multiply. You get negative 4, dun dun dun. Nope. You get negative 1. So close, but so far. All right. Not 0. So not a factor. All right. So what we want to do is they throw in this last part, use the binomials that are factors to write the factored form of f of x. Oh, yay. So what we have here is um, we have x cubed because it's x to the fourth. So we go one lower. Oh, we're looking at, yeah. So we go one lower, x cubed minus 4x squared minus 1x plus 3. And then we have that x plus 2 also works. Yay! All right. And then, yeah, we just write like that. And sometimes we can factor it more, sometimes we can't. Yeah, in this case, we can't. So there you go, that's it. And that is it for this section. Let me put this in the notes. Yep, there you go. All right.